Hi, I'm Tom Stephenson and welcome to Lecture 5B of Jobsite Management. So we're going to be continuing on this important topic about site logistics and job site layout and control. They're very important areas of the construction management process, and they really do come under largely under the realm of the site superintendent. Of course, a lot of things have to be coordinated with the PM, especially contracting particular parties of work, etc. But as far as the best avenues for logistics, usually that's coordinated through the site superintendent. And I'm not saying that the site superintendent comes up with all the ideas for it. They resource it. They, on bigger projects, there may be a research division that the company even has that assists with some of the complex areas. But typical stuff that we've been talking about is usually coming through the site, because that is where everything is happening. So we'll continue on with our look at the goals of a cost-effective job site. As you recall, we looked at productivity rates in the last lecture, and we'll be talking about what kind of space do we have in this physical location, and how do we plot things on a site plan to determine what's the best avenues for that. Google Maps can come in pretty handy of giving you an aerial view of what's going on in the site, and sometimes just plotting things on a Google map can be helpful, as well as site layout drawings that sort of you can coordinate with different phases of the work at different time periods where you're going to be. And we have to think about equipment considerations. Now, we're not getting too much into the methodology part in this section. We could have, but it's an area that needs some further discussion. Is what methodology are we going to approach the project? Are we going to use one pile driver? Are we going to use two pile drivers? Are we going to use three pile drivers? And how does that impact our time frame? And like sort of the image that I left off with in the last lecture, where there was a whole bunch of people cutting the grass and not too many were doing things. Well, we have to make sure that if we're going to invest in the extra equipment, it's going to be utilized and it's not going to be in the way of other things being done. So we have to think about those things logistically when we're doing our site layout and our phase layouts. So we also have to think about restrictions and special permissions, and we'll get into that. There's a bunch of them that we have to consider. Anytime you're dealing with a third-party agency or regulatory authority, you gotta treat it pretty cautiously, because they're not hired by you. They're not really on your timeline, and we talked about time, cost, quality. They're not going to be necessarily all that responsive to your needs. So that means you got to be very proactive and try to get ahead of the curve in these areas. If you have a day early that you can submit a permit, you want to take advantage of that, because every day is lost time potentially if the permit doesn't get approved in a timely fashion. And so we'll also look at some examples of different areas where the job site's been organized, some samples that I've taken some pictures around, photographs, and discuss some of the things going on. So equipment constraints, point of delivery, can we get the size of the equipment onto the site? Can we get it accessible? Site access for people, we think about those areas as well. So we'll go through a bunch of these and the sequencing and location of temporary facilities. So we'll get into that. So site controls, layout and equipment. So point of delivery, traffic patterns, large enough space for delivery vehicles, accessible for loading equipment. Maybe you've got one loading dock, and if all your trades order equipment at the same time and supplies at the same time, you're going to have delivery trucks wrapped around the block. So that needs to be coordinated, and you have to sort of set some rules and processes in place. And we started the course by talking a little bit about processes and systems, and you definitely want to have some processes and systems so that things don't just get out of hand. And so if a trade is going to make an order, they have to coordinate it through you, that it's going to be delivered at such and such a time, so that you can make sure that they have time in the queue to get into where they need to go, like a loading dock. Or you might have to consider, if you've got a lot of things going on at one time, that you'd have after-hour deliveries instead of hour deliveries during the daytime, or perhaps not during rush hour if it's a busy street where you're located. So you want to think about that in queuing areas, so where you can line up for your trucks. So you can almost see here, there's actually two dump trucks here, and there's an excavator over here. What you don't see in this photograph is over here on the street at the side, there's about 2 or 3 other dump trucks. It doesn't take very long for one of these to be filled, and so there's a continuous stream. Trick is not to have too many. You don't want to have too many lined up, because that's waiting and that's waste. So what you want, ideally, a perfect system would be, you have one truck waiting here, you've got one already backed into position, so that when this one pulls out, it just backs straight in. Not that it drives in, turns around, and backs up, and then that makes the excavator wait. So you're looking for this continuous flow of work as much as possible within reason. And we talked about the most responsible time in the last section. So, you don't want to have it so that it's continuous flow and then all of a sudden you're short of a truck and then it's wait time. So there's a balancing that goes on. And it's challenging to be sure. But as I mentioned, it's actually a lot of fun too, coordinating all of these things. So yeah, and as I mentioned too, you can see there's driving equipment for your shoring. There's 3 of them there. So there's basically 3 drivers. And that can significantly reduce your time. Now, at the same time, this is a pretty big space. It's going to be a very large condominium that's going in here. It's got like kind of an L shape, if I remember, from the sales center. And so it's going to be a very large condominium. But the other thing is they do have extra staging areas where they're going to build future condominiums there as well. So it's really quite a complex area. This is the old Canadian Tire warehouse lands, and there's about 18 to 20 condominium buildings over the next 10 years going in. I think they've already done about 8 or 9 of them. You can sort of see some of them here, and there's a bunch around the corner over here, and there's new ones going up along here. So large site layout factors, you're going to need temporary fencing. You have to protect the area, you have to keep it secure. You have to put in temporary roads often. I think I've got some example photographs showing some of that. Maybe you've got to put the temporary roads so that you can get access to put your shoring equipment in before you start excavating. Sometimes that happens. Sometimes you'll put in the permanent road, but you won't put the final layers of asphalt until the project's almost complete at that point. So it just depends. And you may need extra equipment. And distance storage areas. Sometimes, and we'll get into this when I do a little bit of discussions on lean in another lecture, you may want to decouple the storage from the site to somewhere close by where you rent a space, and then you just take it short hauls between that space and the site if it's equipment or supplies that you want to be sure that you're going to have at the most responsible time. Sometimes that happens. It does get to be pretty complicated. This was when they were actually putting the York University subway, which they completed about 3 or 4 years ago. And this was Keele Street. And so Keele Street was basically wide open, a lot of equipment in play to do basically their open excavation for it. Instead of drilling the tunnels, they actually did an open excavation for it. So that is a lot of logistics when you talk about traffic patterns and single lane traffic and rerouting and coordination becomes complicated. Eglinton Crosstown that they're doing, or the Ottawa LRT, you can imagine the disruption it causes for local businesses that are going on, and trying to keep them viable during this construction process is very, very challenging, to be honest. And you can expect, if you're a construction consortium like a P3 putting together one of these projects, that you're going to get a lot of pushback from the local business associations, because it's difficult for them when nobody can park and nobody can drive and there's all these issues. It can be difficult for a 3 to 5 year window of time, right? So those are some of the things that you have to work out the processes on. you have to think about special permits, not just building permits. We kind of talked about building permits, but specialty permits. And do you know all of the specialty permits that may be required? You could have environmental permits, specialty permits for wildlife. If it's salmon are spawning and you're doing a bridge, you might not be able to do any work near the water as it could disrupt the spawning salmon. You could have situations with what am I trying to think of right now? You'd have situations with airports and special permit requirements just to put up a crane. There's all kinds of these permits that might not even be aware of until you actually get into something. So, is it on a busy street? If you want to shut off a lane, you got to get permits for that. If you want to work overhead or above a sidewalk, there may be protections that you have to put in for the pedestrians that are walking by. There may be requirements for to get some of the lane closures during certain specific times, like rush hour, 4 o'clock to 6 o'clock. It may not be possible on some streets. And so you might have to change your delivery patterns and delivery times to after hours. Down when they were constantly doing the work down at Union Station, well, look at the logistics on Front Street, and you have to have temporary sidewalks and walkarounds, and then you have your work areas, and you have to have your staging of your equipment, your temporary washrooms. You have to get your equipment in and out during these periods. And Union Station has literally tens of thousands, if not hundreds of thousands of people that go through it on a daily basis. So you've got all of that congestion of people and their safety and situations that have to be facilitated and coordinated. So these are all complex issues that need to be worked out. You may be lucky, like this is a downtown area, and they managed to get an area of a lane closed off and the sidewalk closed off. So you may be lucky and you may be able to get it. There's not much traffic, believe it or not, in this particular area, so they were able to get that done for that. So sometimes you can be lucky too. Noise restrictions. Well, if you want to have some fun, Google New York noise code, and you'll see a pretty extensive document that if you want to do work in New York, the noise code that you have to comply with and the decibel ratings, and you think you're going to work certain hours, or you fall behind schedule and you think you can make it up by working longer hours, it's very doubtful because you're not allowed to make certain noises after a certain period of time. And so a lot of urban municipalities will have their own noise codes and limitations. Toronto has a lot of limitations of when you can do work and the type of noise that you're making, and there's special requirements to do that. And I even heard that when the Eglinton Crosstown was being built, so it's a government project, right? And it's falling behind schedule, and they still want to finish on time. Well, one of the solutions is you work longer hours, but then there's noise, and so then you've got the city saying, no, you can't work those extra hours. So you got one level of government wanting you to do it and another level not wanting you to do it, and so that can be quite complex as well. Very remote areas are challenging because this is in Alaska. You can imagine it's pretty remote there, and it had no particular road that you could drive in on. You came in by boat, and so this particular area, you would have to do some planning if you're doing some construction, because it's not like, oh, there's Home Depot, we're gonna go get this, and this. You have to have your orders tight, your quantity takeoffs tight, so that you have the right material come. If you miss something, you might have to fly it in, but it's probably too heavy or too big or too costly to do that, or you have to wait. So it's not just running out to the store and grabbing something. So that's some of the advantages that in a large urban center you can get a lot of things. Not specialty fabricated things; those things take time. But off the shelf type things you can generally get. But you get into remote areas, you can't make those assumptions. And even in places like Newfoundland, it's an island. So if they don't have it on the island, then you're going to have to wait for it to be barged in. Speaking of barges, if you're in an island or even doing work like on a in Muskoka on one of the islands in Georgian Bay or something of that nature, you'd have to have a barge if you're going to have concrete poured on the actual island. This is over here is a picture I took at Lake Placid. So depends where you are, right? Other specialty permits. So as I was getting to, road closures, sidewalk closures, lane closures. And these are approvals by the authorities having jurisdiction. So you have to make sure that, again, they work on their own time frames. Railway lands. So railway lands down by Union Station, again, some of the big hotels, the Delta Hotel, big shoring going along the railroad tracks going into Union Station. That carries all the GO trains into Union Station. It carries a lot of freight trains through Toronto. Do you think that the railway authorities are not going to be concerned about somebody doing shoring right next to the tracks? And if it gives way a little bit and the tracks distort, it could cause a derailment. So there has to be a lot of checks and balances and approvals, permits that they have to have checked, reviewed, and approved. And that can take literally months. So you have to make sure that you understand where you're going to have to get these special permissions ahead of time, so you're on them, so you have the shop drawings done, so you have all of the requirements met, and you're not wasting their time, and you're not wasting your time or your client's time. Even putting up a crane near an airport or a military facility. You can often require a special permit for that. Downtown Toronto, a lot of times with the cranes, you have to have it coordinated because, like, Sick Kids Hospital has helicopters that come and go with emergencies. So there has to be a coordination with the cranes that are operating downtown to ensure that they can have access. Fly zones like around de Havilland Airport, basically around Yorkdale. They want to put a crane up at Yorkdale to do something, a mobile crane, they have to get a special permit because it's in a flight path. So you have to look at where's the flight path and what are the requirements that we have to ensure that we're okay. And what's worse about some of these things is they don't communicate with each other, so it can be quite a complicated process. So this is like the shoring going into Union Station, and so long permit requirements, extensive work has to be covered on those things. Here's a luffer crane. I mentioned overhead rights before, so you got a luffer crane that's working on a condominium building. So again, you can't. This would be one way of avoiding the overhead rights issue if you've got neighbors that have an issue. And there were houses actually down below here, so I suspect that's what was going on in that particular case. It can be actually not bad if you're a property owner and they want to build on your property, near your property. I had that in my last house. There was a condominium going up, and I think the builder thought we didn't know about overhead rights, and so I see the tower crane going up, and it's a really big tower crane, like big circumference, and so talked to them, and they were kind of like ambivalent about it. So the neighbors and we got together, and we got there's a construction lawyer that we knew, and lickety split, you get a nice little payment out of it. So sometimes it's pretty good doing those things if you're a homeowner or something. If you know about those things, I think sometimes they think they can just do it and then they'll see if something happens. But generally in this day and age, somebody will usually advise somebody. So you want to be more proactive on these things. The best builders, they are proactive on it, and they make sure they get all the rights signed off and everything is good, and then they can go from there. Flight paths at an airport, tricky stuff, as I was mentioning. One party doesn't coordinate with the other. So there's usually 3 government agencies that you got to get approval through. One is Transportation Canada, Navigation Canada, and the airport itself. And they don't talk to each other. So you got 3 separate approvals, and you have to coordinate them and get those approvals, and then you can put up your crane. So those are some of the issues. I'm not talking about just working on an airport. This is actually a airport project. I think it's at Calgary where I took that one. But like a Yorkdale, it's on a flight path. It's close by. You're going to have to get the approvals. So construction technology and the methodology, as I was saying, there's a lot to think about with methodology of use. You can Look at First Canadian Place as a good example of this. First Canadian Place was, well, it's the BMO Tower downtown, but it still goes by the name First Canadian Place. And it's about a 60-story building covered in Carrara marble. Very beautiful at the time, but the Carrara marble over time, freeze thaw cycles. Some of the marble started to fall, like 30, 40 floors. So they had to secure it and they had to reclad the whole building. So using methodology, a different methodology. Well, first off, Brookfield Properties put out for an RFP, a request for a proposal to reclad the building, and they got a number of proposals in, but the time frames, they were all too long. So what they did was they didn't accept any of them. They put it out for RFP again. And Ellis Don, a curtain wall supplier from the US, and the consultants, they worked collaboratively to come up with a system, a 3-floored system that basically allowed the top floor, the curtain wall, that's the outside cladding of the building, that's the windows, that's the marble, to be taken off. So the upper floor to be taken off. And then after that's taken off, another crew starts taking up, well, that crew moves down one flight, and then another crew starts putting the new cladding on the top floor. So basically all the time you have one floor coming off and one floor going on. So instead of taking one floor off, putting one floor back, you have one crew always taking off and one crew always putting on. What do you think that does to your schedule? Cuts it in half. Cut the schedule in half. You get the project, right? So that's another fun thing about construction, is trying to figure out better ways of doing things. And there's always a better way of doing these things. So methodology can really, really dramatically change how we do things. And I'll have to bring up, there's another case with Calgary Hospital. I'll have to bring it up in a future session, which is really interesting with the hydraulic formwork, how that saved 6 months on the schedule and about $140 million. So there's these cases that you can find, and the First Canadian Place, you should be able to see it online. It's an interesting case of how they removed it and reapplied it. So think of the different methodologies and what's the best one in a particular circumstance. So when we think about material storage, we think about the storage needed, how much, do we have adequate access? Surface area must be compact and solid. Like, do we have to have it compacted ahead of time? Keep it off the ground, that water's not damaging anything, and protect obviously weather sensitive materials. So these are all things that we need to think about. And this little last one here is a big one too. Consider the subcontractor needs. And be careful with that. Some subcontractors want to bring everything to your site because they got a deal on it or something, and then it's blocking up your site, and it's like a nightmare. So you've got to be really coordinating well with your subcontractors. Just-in-time delivery, and this I've already kind of alluded to in the previous session with most responsible time frame. All right, so in construction, there's no true just-in-time, but just-in-time means that you're trying to get it coordinated so that things come as you need them. So I think a good example of just-in-time was what I saw Bird Construction doing at the engineering building at University of Toronto. So I teach right across the street, and I've also done work with Bird, and so they had this very well coordinated, the curtain wall system. So even though it looks like brick on the outside of the building, it's a part of a precast system, and every day they had the precast that they were going to install that day for the engineering building delivered, and then it was put on. And so it was like this continuous flow. They don't have any room down there. Like, it's very, very, very tight area. And so it was a just-in-time sort of delivery system that was invoked on that. It's different if you've got a lot of space. You might do it a little bit differently. Job site offices. Well, you've got your offices, you've got the trades offices. Do you have rooms for meeting in? And the way they can assemble trailers today, you can do all sorts of different things depending on your space. So sometimes your space is really tight and you might have to stack them on top of each other over a sidewalk. And sometimes you've got enough space that you can join them up and have some really good office space. And sometimes you don't even want to have a portable job site office. You want to rent space in a building across the street, perhaps, if that works out. Maybe it's a vacant store or something that you can rent for a couple of years. So that happens as well. So needs to be obviously secure and normal kind of stuff. High-speed Wi-Fi is indispensable, of course. So all of these things, and cases for a plan table, or you may have for a big screen that you can look at while you're discussing them in meetings, etc. So there's a bunch of different things that can be sought out with that. And you have to consider cost and, again, what you're going to use. So as I said, existing buildings, modular units or trailers, these are very common solutions. Sometimes even the offices may be even cantilevered outside the building on steel beams on a multi-story floored building, just to be used that way. Or they may take a few bays in a condominium structure and make that a temporary office and come back and finish that off later on in the project. Different approaches. Temporary facilities. So we have to think about all the temporary facilities, access points, how many gates are we going to have to enter the actual facility. You can do a job site layout drawing for the project, and I've got a couple of samples coming up, or at least one. Security fencing, material drop-off, unloading locations, the material hoist that we mentioned in the previous lecture, material staging, where are we going to put garbage bins? Is it a lead project? Do we have to separate the garbage? If it's in a large urban center, maybe there's suppliers that you just put it in one garbage and then they separate it. So there's different prospects that can be done. If you're excavating but you're going to reuse the soil, where are you going to store it before and you backfill it or reutilize it? Some of the things, the size and scope of the project, you're going to need your office, consultants' offices, and if it's large projects, and subcontractors' offices, washrooms, all of these areas here, and you get an idea. And what you need to have when you're developing a site logistics plan is a checklist that you can utilize so that you don't miss things. So you can use that in your planning approach. Checklists can be very helpful that way. I'll talk about checklists in another class. So here's sort of a site plan showing where you've got fill area, material laydown area, the proposed building, etc. And then you can also determine the finished landscaping and grading and how you want to coordinate that within the construction process. So maybe you can put a sub-base down that'll make it easy for you to drive on temporarily, and then that sub-base could be reutilized and then form part of the permanent base. There's different approaches that you can take to that. And where's your entrance areas? Where's your potential for entrance areas? And how does this work for all phases of the project? And do we have to switch things at a certain point? Maybe when the fill is gone, maybe we need to work in this area, or we need access over here, and maybe it's easier to make the laydown area somewhere else. That's always a possibility. So this sort of high-level shot of, this was the George Brown College waterfront campus being built. You can see what I mean by the trailers. They're being put together, so they can do a lot of things where they put sections together. They come on trucks, 1, 2, 3, 4 runs, but inside there's openings, and you can have a large meeting room with the trades, M&E subs and the consultant trailers. Garbage being separated into different boxes. The material hoist is pretty much right here at the edge of the building. So you got your laydown area over here and staging area over here. One gate over here. There was another side gate, I believe, on this particular project, but it's out of view. So it's a well-coordinated site, sort of orchestrated. There's your temporary washrooms, and they have other ones in the back, so they got plenty of that, so very short walk distances. Propane storage, properly done. Another one here, and usually on these drawings they'll put a radius to show the radius of the crane, and then you're also looking at, okay, so it's going over the neighboring property, so we better get special permission. You can't lock a tower crane, so if there's high winds in that, it has to be able to move directionally. So you can't say, okay, well, I'll lock it, it'll never go over that property. It will. So that was the permissions aspect of it, and that's where if you can't, then that's where you might look at a luffer crane instead. Get the permissions. So a setup site, if you're doing some prefab on site, bending for reinforcement, formwork, site offices. Again, you can sort of get the drift of it, right? You got concrete being mixed on site, so you have, this would be your area for your mixing zone. This is a community center that was being built. We talk about temporary roads. So this road here was temporarily built. This ramp was temporarily built so that the pilings could be put in and along here. And because this is all going to be excavated pretty deep in the future, but you need to have the pilings because up here the backyards are pretty high because it kind of sloped off the ground before, just off of a hill. And so you have to support that because otherwise it would collapse all these houses, their backyards, right? And could even do worse damage. So basically the pilings came in, the ramp goes up, you got your concrete truck in place here. So the site is laid out, you got temporary fencing along here. And now as the work goes along, you can see the pilings are in place, the excavation is going deeper. Things are sort of set up down the side again with the shoring both sides. The lagging is being filled in as it gets deeper and deeper, the excavation work going down. Then you got a ramp. This is being currently removed, but they had a ramp so they could get equipment and they could get various things down to the bottom. So they built this ramp down here, whereas before it wasn't even there. And you can see the tower cranes are in here. They're not. There they are. So basically things are advancing. And now you can see the tops of the tower cranes in this shot, and they've been starting to put their walls up against the shoring. The rebar is going in place, the columns are in place, the foundations are in place. So that's coming along, and of course you get the winter. So this is one winter, and this is a previous winter. So that's not the same winter. So they were kind of slow coming out of the ground. So here is another example. This is Young and Bloor. This is a 100-story tower being built at Young and Bloor. This is on the south west corner. And look, they had to hold up this. It must have had some sort of heritage issue, heritage background. And so this had to be supported while they do the construction around it. What a job that is, right? To try to temporarily support this while the rest of the building's being built around it. I think I have to go back there. It's probably past that I can see things, but I think that eventually they ended up tearing this down, but I could be wrong. One of my students was telling me that when he was there, so I could be wrong. And because there's no space, see what they have here is they've got basically your tiebacks going in. You can see the rakers just off to the side. The tiebacks are drilled and grouted into the ground back, and that's holding the shoring from collapsing. All right, this one section here, you can't really see it that good, but there's rakers going along. Well, for one section of one property, I'm assuming they didn't get permission, so they had to put basically these rakers to secure this, and they're basically tied to the ones where they had permission. So it's kind of a short section, one property in width. I think they're about, I don't know, 40-foot lots wide, so probably about 40 foot. Here, well, there's no permission. Like, you got other buildings here, you got other buildings there. There's no permission, so you can't be puncturing the side of another building. So in this case, the bracing is on the interior. So that means you got to build around it. All right, so all the while you're building around it, it's like a pain. It's like in your way, and you gotta form around it, you gotta pour around it. Now, once the concrete floors at the different levels are in, well, it's not going to collapse at that point. It's fine. It's structurally sound. But during the process, this has to be done on the interior, so that makes it more complicated. Here, note the trailers, and underneath the trailers, you walk. So there's basically a sidewalk that goes underneath the trailers, and these are above ground. And here's a staging area for the concrete. So what they did was they put a ramp, and it's like built on these columns here. And this is specially designed so that they can bring the concrete in and out, and either bucket it up or pump it up, depending on how they're deciding to do that. So it's very intriguing, because you gotta believe Young and Bloor, no space, like really busy. So the challenging project, and it's a mammoth project. This is Bloor, the other project that Tucker High Rise and Great Gulf did on the other side that I think I mentioned in the previous lecture, which is the 80-story tower. This is the one that had the really fast moving elevator system inside that they were utilizing during the construction process, and it was really a big deal for them. So here we've got our temporary power. Gotta have it. So you want to make sure you have temporary power located in the proper spots. I always remember there's this builder that's building up in Collingwood, and I couldn't believe that they didn't have temporary power for the workers on this. There were 2 strings of townhouses, and all I heard was swearing and cursing, and this generator not working. The guy trying to start the generator, he'd start it, go start the circular saw or the skill saw, and then the generator would die, and then he'd curse and swear and march back and try and start it again. And it was a lot, not a ton of houses, but even one house I'd have temporary power, never mind 24 townhouses. After that, I noticed the next series of houses, maybe a different site super, they had temporary power everywhere. So that's progress, I guess. Temporary washroom. So this is actually in George Brown College's waterfront campus. So they set up temporary washrooms inside, because then they looked at it, well, if they're going to go all the way downstairs and then out to the outhouse, the temporary washroom, better we'll just set up a temporary one where the existing washrooms are going to go. And so they did it that way. Job site security, so the fencing, always got to make sure that there's proper fencing and that it separates the area and it makes it safe. And you typically will have security cameras, video cameras. Today they'll have video cameras, and then if they see something, there will be a security person that'll talk through the mic at people and say, leave, or police are on the way, those kind of things. Perimeter fencing, and also signage with maybe marketing the building. Maybe City of Toronto is asking Eastern to put this signage up on this project, illustrating that they're building a community center, and even saying when it is. That's always challenging when they advertise opening, completing. Now, they don't say when in 2021. I'm going to say December 31st, 2021, because they didn't give you a date, right? But still, that's a lot of pressure. They did that with the LRT in Ottawa 5 years out, and it's like on track for 2019. Everywhere, signs everywhere. And then it was like 2019's here, and it's not done yet. It's pretty close, though. Might have been 18, said. So I showed you some of the access roads. Again, you might even put in the road that's going to end up being the finished road, because they got proper curbs in here. So there's a key in this poured concrete. So later on they'll put the finished curb above that'll tie to the key, and they'll of course put another layer of asphalt on it. They'll probably have to do some repairs, because they're going to have a lot of heavy equipment and a lot of heavy trucks coming in and out here, but it does make it very easy. They're not in mud. They don't have to be graveling it every few months because it's sunk and that sort of thing. So probably a smart idea to facilitate it that way. That'll help them with their work. But this is quite a long way, years, I would say, before this is going to be used for regular kind of traffic. As I mentioned with the signs and the barricades there, helps. So in summary, you saw a lot of different examples, and you've seen a lot about the process and things that need to be considered during it. So, we have to consider delivery access. We have to consider material storage and logistics, accessibility through roads, material handling and lifting equipment. What do we need on site that is going to move us forward? And you know what? You can coordinate a lot of equipment too with the various trades. So sometimes a trade may have a specific piece of equipment. Well, does it make sense for every trade to have that specific piece of equipment on site? Now you're overrun with this equipment taking up all this space if you had 3 of these. Whereas maybe you can work out a deal with the sub-trades that they share it, or the one trade gets their laborer to move some stuff periodically for another trade. That can be a big cost saving. Same thing with scaffolding. You put up the scaffolding, maybe the brick masons put up the scaffolding, but maybe there's something that needs to be painted, or something that needs to be something other work done. Well, maybe the scaffolding could stay up an extra day and that trade could get in and do it, and that could be coordinated. Those types of things. No point in taking down scaffolding and somebody else coming and putting scaffolding back up. You're looking for efficiencies wherever possible. And that'll help you, that'll help your project, that'll help your subcontractors, that'll help your clients. All good stuff. Okay, so hopefully this has given you a good understanding of site logistics and some of the things and considerations that we need to work out for every site. Every site is unique. Every site has constraints, and every site has opportunities. If you do something better than your competitors, it could be the most constrained, complex, tricky site going, but if you can figure out how to do it, it could mean a huge win for you as a developer in this particular case, to be able to construct a 100-story tower in probably one of the most prized locations in Canada. Big opportunity. So constraints, yes, but opportunities as well. So with that said, I'm Tom Stephenson signing off for now, and we'll see you in the next lecture. Have a wonderful day and a wonderful week. Bye for now.